Okay, this is video number 3 for Math3430. Let's bring up Spider. And let's talk a little bit, oh, I don't care about that right now. Let's talk about this, let's talk about variables for a while, and then we'll talk about functions. So there's an adage that Python doesn't have variables, it has labels. So if I do x equals 15, then if I do print the value of x, I get 15. So the way to think of that is that somewhere there's a box in memory, a memory region that stores the value 15, and you've placed a sticky note with the x on it on top of that box. You can take it off and paste it elsewhere. So that's the way to think about it. If I do y equals 20, then I can combine them in an expression, x plus y. And I didn't have to say print because this is a read, evaluate, print loop. So when you type a statement, it evaluates it and prints the result and then goes to input. Okay, so when you have an expression like that, it means look up the value of x, look up the value of y, add them together, that's the value of the expression. So I could say z equals x plus y. And then z, the value of the expression just z, is 35. Okay, and then of course, so when you have an assignment statement like this with the equal sign, it means evaluate the expression on the right. So look up x, look up y, add them, that produces a value, store it somewhere and label it z. Okay, so evaluate the right-hand side and then label that by the left-hand side, or if you like, put it in the variable on the left. So there's this famous equation. Let's see, x is 15, x equals x plus 1. Now, of course, in mathematics, that's a stupid equation because it couldn't be, x can't be equal to x plus 1, right? Because you can cancel the x, subtract x from both sides, you get 0 equals 1. That isn't good. Excuse me. So, but in computer jargon, it makes good sense, and you use it a lot. Namely, you got a 1 constant. You look up x, you take x plus 1, and then you stick that in the variable on the left side, no matter what it is. So the old value of x is overwritten by the new value, which is 1 more. So that's a perfectly good statement in computer code. Okay, so you'll notice that expressions give you values, which you can label with variables. All of these values have a type, and you kind of sort of have to think about that sometimes. So the type for an integer, 24, you could say type. What type is this? And it's int, integer. So just like in math, it's integers are whole number is no fractional part. But of course, a lot of times when you're doing calculations, approximately with numbers in a certain number of decimal places, you have to do decimal numbers. So if you do 24.5, What's the type? It's float, which is the way it goes. Okay, so that's a floating point number. And you can convert one to the other. If you want to convert a integer to a floating point number, it's easy. So I want to do 23. So I can say int of 23. No, float of 23. And I get 23.0. So it has a decimal part, but the decimal part is 0. There's also the old programmer's trick of multiplying by 1.0. I don't know which is, probably the float thing is faster. Okay, and if you have a floating point number, say 23.75, you can get an integer by doing int of that number, 23.75, and so you get 23, but note that that is not the closest integer. It truncated, it just throws away the fractional part. If you're calculating stuff, it's probably easy, probably what you want is round. 23.75 gives you rounds to 24. So that's not you don't use conversion to int that much like that. And there's another type you could do. Let's do it for the moment. You could say s equals quote hello unquote. So what's the type of s? It's a str, string type of character, string of characters, and we'll see all sorts of ways to manipulate strings later. Let's see what happens if you say string of 24, 34. Why not? It's got the quotes on it, so that's this character 3 and the character 4, not the numbers. And if you say int of the string, oh, I'm on the wrong operating system. So you can convert the string representation to the number. Okay, so that's the types we'll have in the immediate future. And then we saw with the turtle module, we saw that we had functions forward, left, right that did a bunch of stuff, and we could use those to manipulate things. So you might want to make your own function. And in the book, he calls them fruitful functions and unfruitful functions. So, for example, you could use the trig functions. To get those, you need the math module, so import math. And you can do, in the math module, we have math.py. And there should be enough decimal places. And then we can do math.sine of pi, math.py. And we get a value. The sine of pi is 0. Of course, when it this is only accurate to a certain number of decimal places, and there's round off error when you compute it. So what it's telling you is this number, and then the e minus 16 means times 10 to the minus 16th. You probably saw that on calculators. So this is 10 to the minus 16th. That's pretty close to 0. Okay. So these are fruitful functions. They return a value. You can combine them in an expression, math dot sine of 1 plus math dot cosine of 2, and it computes them, adds the values that it gets back. Okay, so that's what he calls a fruitful function. And an unfruitful function is like one like the forward or turn. So we could take an example. Let me say first to people who are frustrated here, if you don't like typing that math prefix all the time, you could do import from math, math, import, sine, cosine, pi. Okay, now you don't have to type the math prefixes. If you do from, we've done this before, math, import, star, then it imports everything from math, but that may cause a problem if there's a function in math that has the same name as one of my functions. I'm going to have trouble. Okay. And we can do an unfruitful function. Let's do define our own function. So we do define f, and then let's do x and y. And we're going to have the function body, that's a block, so there's a colon here, and we indent the function body, which this console is doing for us. So let's say print x plus y. And then get out of here. Okay, so I have a function. If I ask what f is, it's a function that just tells me. And then I can do f of 10 plus 20, comma 20. So the x gets replaced by 10, y gets replaced by 20, and then, excuse me, this expression then evaluates to 30, and it prints the value of the expression. But it doesn't seem that function returned a value. Is that really true? Well, let's see. Let's get the value of that expression, f of 10, 20. And it's 30. It prints 30, but what's z? Well, apparently nothing. Type z. None type. How about print z? None. So an unfruitful function does return something. It returns the value none, which is the only value in the type none type. Good for placeholders. Okay, so how do you make a fruitful function? Well, you need to return a value. So let's do f def g of x and y is return x plus y. Okay, so that's the body of the function. So if I take g of 10 and 20, the value returned is 30. So I like to call these things the formal parameters. When you write the function, they're placeholders for what you're going to put in when you call the function, which are the actual parameters. So if you give it the actual parameters 10 and 20, then it goes to replaces x by 10 and replaces y by 20, replaces the formal parameters by the values you give as the actual parameters. Okay, so the return statement means stop executing the function, go back to the calling program with the value in the return expression. So anytime you hit a return, you jump out of the function and go back and execute the next line in whatever the calling function, whatever called the function. And you can use a return, so it doesn't matter how deeply in the code the return is buried. When you hit return, the function stops executing and you go back. And of course, you can do def h of x, y. Let's do colon. Let's do print x comma y, x plus y. And then I don't need this, but return. So h of 20, 30, prints 50, but doesn't return a value. So you can make an unfruitful function. You can use return nothing. It's useful sometimes to do that, but to jump out of the code somewhere. If you leave off the return, then running off the end of the function definition means return nothing. Okay, so there's one more thing I want to say about functions here. Let's do exit to make this thing reinitialize, get rid of everything in the memory. So let's do x equals 1, y equals 2, a equals 3, b equals 4. And let's define a function, def f of x and y. So let's do a equals x plus y, b equals x minus y, and x equals a plus b. Okay, and I'll just run off the bottom of the function. So this is an unfruitful function that, what does it return? Well, I don't think it returns anything. 20, 30. Yeah, it doesn't do anything. That's not so exciting. Let me edit this definition. And let me add another statement. Print x comma y a b. Okay, that's a little more sensible. F of 20 and 30. So x is 10, which is Well, let's see. A is, you replace the formal parameters by the actual parameters to replace x by 20 and y by 20. So 20 plus 30 is 50. So A is 50. And then B is 20 minus 30, that's minus 10. And then X got changed here to A plus B, which is 40. And the formal parameter Y just has the value 30. So that's nice. What about these values back here in the program? Did I mess with those? And the answer is I did not. X is still 1. Y is still 2. A is still 3. B is still 4. So inside the body of a function, the names are local to the function definition. They don't affect variables of the same name. They don't interfere with variables of the same name in the program, in the calling program. And the formal parameters are the same way. It doesn't matter that I called these the same as two variables up there. It's just the formal parameters. Whatever you put in for the first thing replaces x in the body of the function. Whatever you put in for the second thing replaces y in the body of the function. So those are local variables. It is possible to reference the value of a local variable, in the calling program. So if we do def g x, y, and then let's do print x plus y plus a. Okay, there's no a mentioned in the body, in the definition here. X, y is not a formal parameter. I haven't used it anywhere, so it must come from the surrounding program, what's called sometimes a global variable, 10, 20, and 33, because A was 3, right? Right here, A is 3. So it's possible to do a reference a global variable. You might say, well, how about if I do this? G, let's call it H of X. Suppose I just want to set the global variable A to X. So I could do A equals X. Oh, yeah. And it doesn't have any apparent effects. I guess it would be good to print something. Let's do print A and X. So let's do H of 20. So X gets replaced by 20, and A got set to 20, but it didn't do anything in the main program. So the rule is, if you assign to it before you try to read from it, it's a local variable. So I assign to A inside the body of the function before I tried to look up A, so it's a local variable to this function. X is a formal parameter. So you might say, well, then how the heck can I assign to a global function, a global variable? Well, you can do def k x global A, print A equals X, print AX. So HK of 10. Z is not defined. I meant to say X, of course. Okay, K of 10. K of 1, let's make it K of 10. So A is, it says A equals to 10, X is 10, this makes A 10, and then 10 and 10. But now I have changed the global variable. Okay, so modern folklore is to avoid global variables because changing the global variable on one page could change your function 10 pages later. You wouldn't notice and you'd get very confused. And the people who are trying to read your code would be very confused. There are exceptions, of course, like math.py. That's a global variable in the math module. You could set pi equal to something and it would work. So it's an input. I'm not going to do it. The point is, it's just a variable. You can set it to something else, which would, of course, goof everything up. And the attitude of other programming languages is they have public code, protected code, private code, so on, to try and keep you from doing things like that. In Python, they don't try to protect it. It's open to do anything you want with it. But we take the attitude that everybody here is an adult. You know you're not supposed to change the value of pi. So don't do it. You know, we'll just trust your common sense. Everybody here is an adult. Okay, so I guess that's what I wanted to say in this video about functions. We'll take a look at some turtle graphics with functions in the next video.